Assalamualaikum and a very good day. I greet all the panelists. My name is Faiz Irfan bin Razali, and today I will present to you about my final year project proposal. First of all, I would like to inform you that I have changed my title from Application of Surface Metrology for Diamond Tool Analysis to Application of Surface Metrology for Two-Flute Milling Tool Wear Analysis. For the introduction, I will start with the definition. Surface metrology is the study of the relationship between some features in a part of assembly that concern with deviations between points on the same surface. This feature refers to the asperities such as spokes and valleys of surface irregularities. The flute milling tool is a spiral-shaped cutting edges which are cut into the side of an end mill, and it will provide a path for chips to escape. Wear is a process that involves the interactions between surfaces whereby it causes the removal and deformation of material from a surface due to friction of motion. The first literature review topic is profilometric-based tool-wear analysis. In research by Metrology et al., tool-wear analysis is done for the machining of high-hardness materials used in forging dies manufacturing. Parameters that have been analyzed are the flat wear (VD) and the refraction of cutting edges (KS) of the cutting tool. Insect wear is captured by USP microscope for two types of optical images, which are axial and radial planes. In phase image and analyzed 144 images, which could lead to a longer time taken to obtain the result. In G. Singh et al. Paper, they used profilometric method to measure diamond tool edge wear at different orientations. The result gives the parameter of depth and width of the tool wear, which was not visualized in 3 dimensions, and how much the wear experienced by the tool. Coherence correlation interferometer (CCI) is used for power spectral density (PSD) analysis on the machine surface, but it only obtains the surface roughness of the workpiece, which still lacks of information to quantify the level of wear. Second literature review topic is measurement datum for tool wear analysis. In research by N.F. Ismail et al., the measurement datum is a factor that needs to be fixed to improve the integrity of grain height measurement. They had detected an unwelcome error in the height measurement due to slightly lower correlation coefficient for peak height measurement. One of the possible reasons for this error is because reference datum for height measurement is only based on average plane calculated from the available data. There is no physical datum, such as machining datum or measuring datum, to relate the tool characterization to the machining results. Thus, the researchers suggested there is a need to define a reference datum to make it traceable to the machining datum. The third literature review topic is reversal method. The paper by N.F. Ismail et al. Had proposed a phase reversal method in determination of reference datum for characterization of cutting edge protrusion on a flat end face of cylindrical cutting tool applied in vertical cutting. Measurement is done in two tool positions, which is the normal position and after the tool is rotated about 180 degrees about the tool cylinder axis as shown in figure. It has no repeatability error, capable to differentiate step height with maximum standard deviation of 0.23 micrometer and can achieve accuracy less than 1 micrometer. In another research by M.F. Ismail et al., this method cannot identify grains in 3 samples due to poor repeatability of measurements in several rotational positions because of geometrical error of diamond-plated tool cylinder. Thus, application of reversal method need to be considered carefully for any cases. From the literature review, several problem statements had been made. First, previous method used consumed time to make data processing. Second, the results presented from tool wear are only in two-dimensional measurements, which does not quantify the overall wear experienced by the tool. Third, physical datum should be fixed in tool wear analysis. And fourth, reversal method can be an option for measurement if physical data fail to develop. In this project, there are three objectives that had been made. Number one, to determine the suitable measurement method using errors-based metrology, whether by fixing a reference datum or applying reversal method. Number two, to measure the tool in fresh and worn conditions and quantify the volume of wear. And number three, to evaluate the method by quantifying the volume of wear. There are several project scope and limitations that had been identified. First, the analysis is only applied for two-flute milling tool, and it would not be the same for other manufacturing tools analysis in the industry. Second, the measuring machine that will be used is Alcona Infinite Focus measuring machine that is available in UiTM Shah Alam. The result will be different from other measuring machine available due to the advancement of each machine. Third, the result will or will not solve the current problems, but there will be new information or knowledge that will be gained. The methodology of this project can be represented in terms of flowchart. The first phase of this flowchart is to answer objective 1, which is fixing reference datum or applying reversal method. Start with the literature review, and then the problems can be identified. For setting two datum using jig, the datum will be set at one end tip of the tool's blade. Two specimens will be measured before wear, and if both have a consistent measurement, the datum will be valid. If not, the option for measurement is by applying reversal method. The second phase of the flowchart is to answer objective 2, which is measurement before and after wear and quantify the volume. For measurements of tool before wear, the machine that will be used is Alicona Infinite Focus measuring machine. For the measuring conditions, 20 times zoom for Alicona Infinite Focus measuring machine and 4 mm times 4 mm area of measuring. For simulating wear action on tool, it will be done by using bench grinder and not the real manufacturing effect. After that, the measurements of tool will be continued after wear. The third phase of the flowchart is to answer objective 3, which is evaluate method. The measurement data will be analyzed using software like MATLAB or Gradient. Measurement data for afterwear is expected to have reduction in x-axis, y-axis, and z-axis. Data from before and after wear can be compared to obtain volume of wear. Each of the point in the surface is measured in pixels. It will be used to calculate the volume of wear by using equation shown. This equation will be inserted in algorithm that will be developed in FYP2. The result for this project can be expected as the figure shows, whereby aerial method able to measure the surface in 3 dimensions. This is an Alicona measuring machine test for a specimen with 2500 RPM feed rate milling process. By using MATLAB, the result shows that the surface is measured in x-axis, y-axis, and z-axis. The height parameter of each point is differentiated by the color scheme. Therefore, the volume of wear can be calculated. The preliminary result for this project can be expected as this result, but it would have detailed process such as surface filtering, mathematical calculation, and algorithm development for wear volume quantification. I think that's all for my presentation. Thank you for your cooperation. Assalamualaikum and have a good day.